Wind can be defined as the horizontal air movement. Wind moves from areas of high pressure to areas of low pressure. This pressure is caused by unequal heating of Earth's surface that generates difference in pressure. An easy way to see the visible difference in air pressure is by looking at isobars. Isobars are the lines on a map that connect points having the same atmospheric pressure at any given time or on an average given period. Isobars show wind direction. Many different factors go into how isobars are shown. Pressure gradients are just one of the few. Pressure gradients indicate that wind moves from high to low pressure, and high pressure molecules want to spread out as they are all tightly crammed. Close isobars mean that there's a high wind. When the isobars are more spread out, that indicates low winds. Coriolis effect also go into isobars, but we'll talk about that later. Friction also goes into isobars because friction allows wind to change directions, which keeps it not parallel to the surface. And friction also goes against the Coriolis effect because they are conflicting. The Coriolis effect. The Coriolis effect all has to deal with the rotation of the Earth. Wind moves in a straight line. Since the Earth is moving, this line looks curved. If the Earth did not move, the line would be straight. The Coriolis effect only affects wind direction, not wind speed. These are both two different concepts. Because of the Coriolis effect, wind direction does not always show high to low pressure. Pressure gradient causes air to start moving and the Coriolis force to start acting as a right angle to that motion. This Coriolis force and the pressure gradient force then become equal. This is known as geostrophic winds. That is usually the upper wind in the atmosphere. Why does air rise and descend? Warm air rises, creating a low pressure zone. Cool air sinks and creates a high pressure zone. The air that moves horizontally between the high and low pressure zones near the ground surface is where wind is created. The greater difference in pressure means the stronger the wind will be. Convection in the atmosphere creates the planet's weather. When warm air rises and cools in a low pressure zone, it may not be able to hold all the water it contains as vapor. Some water vapor may condense to form clouds or precipitation. When the cool air descends, it warms. Since it can then hold more moisture, the descending air will evaporate water on the ground. Air moving between large high and low pressure systems creates the global wind belts that profoundly affect regional climate. Smaller pressure systems create localized winds that affect the weather and climate of the local area. How general circulation affects climates in certain areas. The circulation of wind in the atmosphere is driven by the rotation of the Earth and the incoming energy from the sun. Wind circulates in each hemisphere in three distinct cells which help transport energy and heat from the equator to the poles. The winds are driven by the energy from the sun at the surface as warm air rises and colder air sinks. The circulation cell closest to the equator is called the Hadley cell. Winds are light at the equator because of the weak horizontal pressure gradients located there. The warm surface conditions result in locally low pressure. The warm air rises at the equator, producing clouds that cause instability in the atmosphere. This instability causes thunderstorms to develop and release large amounts of latent heat. Latent heat is just energy released by the storms due to the changes from water vapor to liquid water droplets as the vapor condenses in the clouds. This causes the surrounding air to become more warm and moist, which essentially provides energy to drive the Hadley cell.